Welcome to Ask and Learn.
Let us start with option A. The condition for reaction to be spontaneous is that the value of delta G should be lesser than or equal to 0. Considering a reaction that A plus B will give us C. For this reaction to be spontaneous, delta G should be negative. Thus, if the reaction is reversed, delta G for the reverse reaction will be positive, hence it would be a non-spontaneous one. So the statement by option A is true. Going towards statement B, the spontaneity of a thermodynamic reaction but the rate of reaction tell us about the kinetics. So kinetics are directly proportional to the rate. A spontaneous can be either fast or slow. Spontaneity and rate or speed of the reaction are independent of each other. So, independent, that leads option B is false, that all spontaneous processes are fast. Moving towards option C, the condition for reaction to be spontaneous, as we know, the value of delta G should be negative. Again, considering a reaction, A plus B will give us C. For this reaction to be spontaneous, delta is spontaneous, the value of delta G should be negative, while if the reaction is reversed, the process will be non-spontaneous and the value of delta G will be positive. While it is not sure that the reverse reaction will take place or not. So option C is false, that all spontaneous processes are reversible. Moving to option D, the internal energy of a system is a function of temperature, and if temperature remains constant, the internal energy remains constant. Mathematically, it is delta U plus Q. Delta U is equal to Q plus W. For isothermal process, the value of delta U is equal to 0, which leads to equation Q is equal to negative of W. According to above reaction, the heat stored in a system gets converted to work but not lost. Therefore, the statement in option D is true, that isothermal processes loses no heat. Moving to option E, the given statement is false because a reversible process is an ideal process in which system goes from one state to other in infinite number of steps. The overall heat is less, but in an irreversible process, the number of system the number of steps to take the system from one state to another is limited, so the heat loss is more.